Been thinking about coming back to Spotify Premium? Now that's a great idea. With unlimited skips and
Hi, hello, good afternoon, everyone, and thank you for joining us. We are live on Facebook. Welcome back to another session of our Pier 71 Roadshows, where we find out more about our innovation opportunities for SmartPort Challenge 2020. So we are about halfway through our roadshows, and we have about 1 more month to submit those proposals before the 10th of August. So if you need more information, please go to www.pier71.sg. So we're slightly just 1 minute before 4:30, but I see some people have started coming in, and I think some people are also watching this live on Facebook, so we'll probably just begin. So the format of today's session will be some presentation slides, but the session is meant to be interactive. So at any point in time, please feel free to type in your questions in the Q&A function if you're in the Zoom webinar, and we will take these questions. If we don't have time to address all your questions, we will still consolidate them and answer them via our social media channels in a post-event coverage. So today's session is on the topic of automation of underwater propeller polishing and removal of thick marine growth on hulls and jetty piles. And today we're very pleased to have with us Hyman and Albert. Hyman is the investment manager of Innoport, and he is calling in all the way from Poland. So good morning to you, Hyman. And Albert is the technical superintendent with Bernhard Schulte, and he's calling from Singapore right here. So hello, Hyman and Albert. Thank you both very much for joining us. And I understand that you have a deck of presentation slides to share with us more about. Yes. Okay, so perhaps we would just let you begin with the session, and the stage, or rather the screen, is yours. So please begin.
Thank you very much. I hope you can also see my screen.
Yes, looks
very good.
Yes.
Great. So yeah, thank you very much, and for giving us the opportunity today to talk about the challenge statement that we posted in this year's SmartPort Challenge, and to give you a brief background on the companies behind the challenge statement. I will start with an introduction on the two companies. First of all, we have Bernhard Schulte, which is a 135-year-old company from Germany, a shipping company with two main verticals, ship owning and ship management, which has also a fairly wide range of maritime services. One of them is Dive Marine. The Dive Marine group includes diving services and hull cleaning services, as well as launch boat services and inspection services in Singapore. Partner in this challenge statement is Dive Marine Services, the diving company, since we are talking about cleaning hulls and propellers, jetty piles, etc. To jump right into the challenge statement, currently we are doing a lot of automation of flat surface cleaning on ship hulls, but we always face challenges when we have curved areas, and that includes, of course, the propeller, which has convex and concave areas to clean, but also around the bulbous bow. And the same with piles when we are called to clean jetties. Maybe I will hand over to Albert now to give a few more details on the actual cleaning exercise.
Yep, thank you, Hyman, for highlighting. First of all, I would like to share with you about some actual photos, what is happening on site. So basically, on the left-hand side is a typical example of jetty piles. So time to time, it requires maintenance and cleaning so that structural integrity of this piles is maintained. This is part of the diving glue job as well. Other than that, as Herman mentioned before, some propeller cleaning or hard cleaning, which is on the center where you can see the propellers. So the two picture on the right hand side is basically about propeller polishing tools. The one on bottom, so where this gentleman with the diving mask is holding, is a propeller polishing tools. And the one on top is a typical brush cut example, which is used to clean the hull of the ships and also the jetty piles. So we'd like to move on to the next slide where we will be showing different systems as well. This is from our sister groups. So on the left-hand corner, you can see it's a propeller polishing tools. Is run by hydraulic, basically polishing with the polisher. And of course, below pipe is mainly for the section of the debris. So with the increasing port restrictions and sort of like preventing invasive species entering into the port water. So making use of this system will prevent the debris or sort of like barnacles and stuff invading into Singapore waters. Other than that, on the right-hand side, you will see different components of the brush cut and accessories. So the yellow color photos are mainly different brush to cleaning different area of the ship hull. But of course, right now, propeller is mainly done by the propeller polisher. Other than that, you will see the hydraulic power pack, the winch for all these running hydraulic hoses. And in the center, where you can see the sort of like debris collection system, where B version for the hull cleaning machines. Next, you might be wondering how is the operation being done. So I would like to show some videos how actual operation is being done. So we will start with the first video first. So this taken from the live video of divers. So basically the diver jump into the water. He will sort of like reach to the propeller area where he will assess the situations. And of course, we are showing some example only. So there are different ways to clean the propeller as well. So first of all, this gentleman, he will do the hydroblasting, sort of like getting rid of the big barnacles before he eventually polished. So he's currently doing hydrojetting to clear all the barnacles. This is another part of where it's called sea chest of the ships, where the ship cooling lines. So time to time, it will have barnacle as well. So currently he's doing the propeller polishing using the polisher. And as you can see, different cup area where not easily accessible by current brush cut system. So lastly is the brush cut system running throughout the hull of the ships to do the hull cleaning. So this system right now, you can see is without the debris collection. So it just clean the hull. And we'd like to move on to the next slide, where showing another type, which is using water jetting for the hull cleaning. So you can start the next video. Yeah. Currently, of course, in this presentation, we are just sharing some of the technologies we never cover all to just get a background info and a real life example. So currently, this machine is running onto the ship hull. This is called vertical side above water line. And currently is sort of like using magnet and rollers to move around the hull. And he has finished the vertical part, which is above water line. So now this machine is going down underwater to do the hydrojetting underwater as well. So you will see the bubble coming in when it's activated and cleaning the hull itself.
Yeah, so as you can see, the automation of the flat surfaces is, we already have a certain degree of automation there. But the surfaced area, so the curved areas is where we really have to involve human divers for the whole process and do the process manually.
Yeah. So this is the live video as well. So next, we will talk about the challenges that we are facing. Definitely, as we have mentioned before, curved areas. So this photo on the left-hand bottom corner is typically showing the ship complete hull underwater part. So basically, the flat surfaces, they are quite huge. So it will be mostly covered by the brush catch machine. However, all this curved area is not easily accessible by the machine. So this is one of the limitations. Other than that, it's also hard barnacles. So basically, different, depending on the cleaning pattern of the ship's profile based on the owner request or charterer request, and depending on the past maintenance. So there might be cases of where very hard barnacle, it cannot be easily cleaned by the current sort of like brush cut or what. So currently they are using different tools in terms of brush to clean different sort of degree of barnacles. Other than that, also on the polisher part for the propeller as well, they are using similar concept. So if they are finally polishing, it will be using very fine brush. Before that, if too much of barnacle, then they will use a half brush. So depending on the cleaning profile. Other than that, currently we are mainly relying on the diver to get the right pressure and right angle to properly polish or clean the surfaces. And one of their QC requirement is also to not to damage propeller or hull or even paint or jetty piles structure. Mainly, currently, human diver are involved, and in this diving industry is quite high risk, as you can notice from the challenge statement. So typically, the main reason we would like to get rid is also human divers, involvement of human diver in future.
And the reason for that is not only the risk involved, but also the availability of qualified divers for those specific jobs. And on top, the restrictions that are coming in various ports. In some parts of Singapore port, it's already not allowed, especially during cargo operations, etc., to use actually human divers on the ship's hull. So there we need a higher degree of automation to react to the market developments that we see.
Yep. So there are quite a number of solutions, autonomous solutions at this moment in the market. I would like to show some example of our own. The one on the left-hand corner is using water jet system, ROV. So it's a remote operated vehicle. But obviously, it's also similar concept of the brush cut. So it cannot get through to the cuff area or the propeller polishing. The one in the center with the yellow color is brush cut ROV. So is using the brush to clean the hull, similar like a diver operated brush cut. The only difference is remotely operated. And on the right hand side, you will see a typical diving support boat with accessory, required accessory mounted onto the boat to do the cleaning job.
But again, these ones are for flat surfaces only.
Yep, exactly. So next is we'd like to move on to, you might be wondering what are the limitations. So I've shared photos of what the ROV machine can reach. So as you can see from this photo, the green color marks are the area that ROV machine can access at this moment to do a proper cleaning job. However, all this sucker area and propeller area and even rudder area is not currently accessible yet at this moment. And other than that, on the right hand side, also jetty. For the jetty, the main problems is that the access for this huge ROV. So you might notice on the top photo of the jetty pass below, they have very limited space. So just now the huge ROV machine, it cannot go through. So it cannot thoroughly clean the Jetty Piles job as well. So these are the current limitations that we are facing at this stage.
Yeah, and on top of the space is the curvature, the different curvature of each jetty pile in the different jetties, as well as the space limitations that we see on the right-hand side. Okay, so I think from here we see that we need new solutions for the curved areas, both on vessels and then also jetty piles. And the requirements that we put here are, of course, things where we say this is what we would like to see the development move towards, right? So as we said, given the risk involved with human divers and also the restrictions that we face in several waters, we would like to move away from human divers constantly doing the jobs underwater to more autonomous solutions with ROVs. Obviously there needs to be a certain ease of operation and usage to make it economical. We need to be able to deploy it from our launch boats or our work boats easily and operate it with the staff that we have. The importance is that we can cover all the hard to reach areas, especially the curved areas, because this is something that we cannot do remotely at this stage, and this is obviously something where you have marine growth that you need to clean as well to complete the job. As we put in, obviously it would be nice to have an all-in-one solution where you're not required to really take the ROV out to dismount or mount different brushes for everything and accessories during operation. For example, the different polishing discs, and then of course a solution that does not damage the paint, because curved areas in the test that we have seen from other companies and operators at the moment is when when they are transitioning from the vertical to the horizontal depending on the ship's ship hull shape, can already damage the paint by the tracks or whatever means they use to attach to the hull. So this is something that where we need to make sure that the hull and paint is not damaged, because obviously this will affect our ability to actually complete the job properly without any claims afterwards. And of course, we are looking for something that has at least the same efficiency as the diver, because often the ROV solutions are not as efficient as the divers, but we're obviously looking for something that is at least as efficient as the diver with a minimal time requirement and the above. We are aware that it will be difficult to get all of what we quoted here above to incorporate all of that in one solution right now, but we are also prepared to support to see that a solution is developed that really makes sense to deploy in the market. And how are we going to support that? First of all, we are a shipping company with a vast amount of knowledge in many parts of the industry. Since we are operating both the ship management business and the whole inspection and cleaning business, diving business. So for any solution out there, since we have access to very different ship types as well, we can act as a sparring partner with a very broad industrial knowledge and expertise. We can provide access to an extensive network so that we can really see how we can get all the stakeholders involved in the development in such project. We can support the development, of course, as well with our expertise, both in terms of ROVs and hull cleaning. as well as the manual diving operations as they are now. So we can always give feedback whether something is practical or not. And then once prototypes are developed, we are more than happy to provide test bedding facilities. We can do that obviously also in real life conditions. We have jobs all the time in Singapore and in and around Singapore, so that we can easily test the solutions on the job to see the workability. So I think this sums up, unless Albert, you want to add anything?
Currently more or less covered whatever the project requirements and also what we can do regarding this project as well. So we would like to request from the audience any question and answer that you might be raised.
Thank you, Hyman and Albert, for the presentation. I think it's really helpful to have all those images and videos. Okay, we have a few questions coming in, so perhaps let's take those on the when you said that it should be benchmarked against the current effectiveness. So you're looking at a solution that is both cost effective as well as efficient compared to the current solution. So we have a question from Lo Wah Sing asking, what is the current indicative charges for underwater hull cleaning? So I suppose that's using human divers right now. Do you have a sort of a dollar per square meter of hull cleaning?
Normally it's charged by the whole ship or like sensitive area where sea chairs and propeller polishing, they are separately charged. Normally our diving departments or dive marine services, they don't charge per square meter. It's more of like how many meter in length and how deep the water is and all these conditions. So, but of course, it's quite costly at this stage because of a lot of human involved and a lot of equipment involved. It can be ranging from $5,000 to $10,000. And obviously, propeller polishing is a separate job, so definitely chargeable for another rate as well, $3,000 to $5,000.
Okay.
Depending on the size of the propeller as well. Yeah.
Okay, so 5,000 to 10,000 US dollars depending on propeller size. And you also mentioned a sort of a time requirement in terms of efficiency. Do you also have a sort of indicative how long it normally takes a human diver at the moment?
It depends on the ships and the number of teams that they activate as well. And normally we will, our diving department, they will follow as per client request. So there are a few solutions. If let's say it's in the terminal, then they have a sort of like approved equipment or approved sort of like cleaning machine that can work within the terminal. Then the time they have to follow with the ship. Normally it will take about 6 hours from all the way to almost 1 day, depending on the ship size and the number of teams. So normally for anchorages, it's allowed currently in Singapore that human diver are working, but mainly the port side, which is alongside the container terminal especially, then it will require us to sort of like use terminal approved, or sort of like MP approved ROV machine. Yeah.
Okay, thanks. And there's another set of questions asking about, so given that it takes a significant amount of time and money for cleaning, would you be considering solutions that sort of prevent the growth from even taking place in the first place? So there is a suggestion from Steen on ultrasound technology, for example.
Thanks.
Currently, I will share with you what are the corrosion prevention systems that are currently in the market. On the larger scale, currently big ships they are using ICCP, they call it, Impressed Current Cathodic Protection System. So it's like the sum of like current emission and throughout the hull to prevent the Panicea from growing. But it does not prevent the algae from growing. So there is definitely sort of like fouling is involved. Then secondly, ultrasonic, so far, the affected areas of ultrasonic sensors are very small. It's practical for the work boats or smaller scale versions, but at this moment, it's not quite practical for the big ships. So they have to mount different, hundreds and thousands of sensors on board, transducer on board, just to do the anti-fouling part. But of course, there are many solutions as well. Some is depending on the paint that they use as well. So these are a few versions as well. Yeah. So there are a lot of ongoing process on this.
We actually have looked at Hasitech that Steen mentions here in the chat. And indeed, it's not yet necessarily practical for the larger commercial vessels. Yes, it works to some extent. So there'll probably be developments that will prevent that will prevent the growth to a certain extent. However, this will also always be this will always mean investment for the owners, and then it's up to the owners to actually decide, the ship owners to decide. As a ship manager, we often do not have any power over the installation of such a system or not. There will be the owner to actually make that decision, and if that decision is not taken, then we will be cleaning. So there will always, in the intermediate future, there will always be demand for the cleaning services, because it will take time before any such system will actually become dominant in the market. So I think there's still enough potential to develop a solution like that, given the current environment.
Just to share with you our experience regarding the Hasitech as well. So currently, there's a few test bed ships that we have installed this system on board, mainly on the seawater cooling line and also on the stand tube area where it's nearer to the propeller. So, but of course, the test bedding is only 2 years at this moment. From what our last observation report for underwater inspection, it proved to be sort of like working fine, because currently they mounted, because the transducer they mounted at the stand tube were nearer to the ship shaft. So basically, it has a coverage up to the propeller, and based on our 2 years experience now, is showing positive result on the fouling.
Okay. So I gather that you're looking for a solution that is for cleaning and polishing purposes. So that should also answer the question here by Han Privet on whether you're interested in a monitoring solution. So I think you're looking for something that is, for now, the market still requires that cleaning solution. So then on that, there are some questions on Facebook asking a little bit more about frequency. So how often ships or Jetty Piles requiring this cleaning work to be done?
Normally for ships, it will be depending on the charterer and the fuel consumption requirements. So mostly it's like based on the demanding of charterer. So it can be from 1 year to 2 years or 3 years. So depending. So example like Mars or MSC, they are requiring our vessel to be cleaned like every 1 year. And then every underwater inspection, they will again check the condition. If there's any sort of like fouling they detected, they were requested for cleaning.
I see. Okay. And we have a question also from Haniza. Are there any environmental restrictions when it comes to performing hull cleaning within port areas? Any of these restrictions that the solution provider should be aware of?
Yes, there are, and they're increasing. So there are, I mean, if you look, for example, at Hong Kong, there the environmental authorities are not allowing any hull cleaning to be done within Hong Kong port waters. Now they are the first ones now to be, I think, approved with that have a debris collection system. And so debris collection system is something that that everybody should look into, because more and more ports will impose those restrictions.
Okay, thank you. Okay, we also have a comment from someone saying that they are from California right now looking into this solution. Yes, we welcome proposals from overseas as well. Thank you for your interest. Please feel free to submit a proposal. We will look through it, and but we do require that the development work is carried out in Singapore. So
and we can also add to that, since we are also working internationally, same for us, we are also welcoming and we'll be able to test in various parts of the world.
Yes.
Solutions are proposed.
Yeah, so we do definitely welcome our international friends to participate as well. Okay, we have about 2 more minutes. Let's see, what other questions do we have? Okay, so current anti-fouling solutions, there's a question on Facebook, do they currently not work? Again, I think we are looking at a solution that does the cleaning and the polishing. Yes. Okay, perhaps then we can just kind of wrap up and summarize. So you're looking at a solution that can perform propeller cleaning, polishing, removal of thick marine growth. The difficulty right now is that many of the existing solutions are on flat surfaces, so they can't do the curved surfaces. Just now in your video, you showed that there are some ship lines or other features. These are difficult to be achieved with the current solutions right now. So you're looking at one that can achieve all these and also reduce or make it safer overall, because it reduces the requirement of a human diver to do it. And this should also be easy to operate and to use and to deploy from the workboat easily. Yes, so that's it. Okay, so thank you very much, everyone. We have almost come to the end of our time. If we have questions that are unanswered, don't worry, we will still take them in and we will still post our answers or contact you separately to give you the answers to your questions. I want to thank Hyman and Albert. Thank you very much for your presentation, your time calling in from Poland and also Singapore. Thank you for sharing with us. And to everyone, thank you for your interest in this. Please, again, feel free to submit your proposals for wherever you are, and we'll be very excited to receive them. And I also want to point out to you that next week we have another of our roadshows tackling 2 more challenge statements, and the information can be found on the screen right now. So please feel free to register, and we will see you again next week. Thank you, everyone, and please stay safe. Take care.
Thank you.
Thank you. Thanks, Hyman. Thanks, Albert.
Bye-bye.
Bye.